Hello everyone, today I'm going to do a video on the MicroLoc work holding system that I bought for my Haas UMC500. I'm really pleased with it. It's done exactly what I wanted it to do. But I found that when I was purchasing my particular system, I found that the information on the internet isn't that comprehensive, so I thought I'll try and get it all in one video so that anyone looking at this system can decide whether it's right for them. So yeah, I'll explain a little bit about it, how it works. I'll explain a little bit about the various options that are available, and then the accessories that you can buy with it. And then I'll also talk about the advantages and disadvantages that I found when working with it, because no work holding system is perfect, so hopefully at the end of this video you'll be able to decide whether it's right for you. Right, so what is it and how does it work? It's a system, or best thought of it as a system. It's made by Micron Work Holdings, or Micron Work Holdings here in the UK. They do seem to have distributors all over Europe. I'm not sure about America and the rest of the world, but they do definitely have distributors in Europe. And what you do is you start out with a fixture plate like this, which is a grid system. And what it allows you to do is take these, which are locators, and these, which are clamps, and position them anywhere you want to either hold small pieces of stock, large pieces of stock, multiple pieces of stock, to really do whatever you want. So that's why it's referred to as a system, rather than you wouldn't think of it in terms of a vice where you're really clamping one piece of stock, or you do get dual vices where you clamp two. This is a system. So how does it work? You take your locator. As you can see, it's got a cross on the bottom. I think they call these tenons, and these locate into the fixture plate. So these are precision ground surfaces and actually quite a tight fit. So if I'll do it on this one. So push it down like so, and as you can see, it's not really moving around in there. You then take these clamps, and those locate in these T-slots on the fixture plate. Take it in like that, bolt them down, put another one in this side, and that's not going anywhere. So think of that as your fixed jaw. Then what you do is get these racks. So these racks have little teeth on them, which correspond to little teeth on the clamps here. So you position your rack, I'll just put it there. Take your clamp, drop it in, so you can move it forward and backwards wherever you want in those teeth. And then do the same, put a clamp in the T-slot, clamp it down, and then put your piece of stock in. And to tighten this clamp and loosen it, once obviously you want to get the piece of stock back out, you put an Allen key in the top here, and it's hidden with this cover, but what you're doing is driving a wedge. So if you've seen an OK vice, it's very similar to that. You've got a wedge. As you tighten it, it drives that wedge down. This jaw is fixed and clamped, obviously using these clamps, so that's not going anywhere. So as the wedge goes down, it pushes this face out, which is your moving face, and that's what clamps onto the stock. It provides a really strong and powerful clamping method, because it doesn't work like a normal vice where you have a screw and then two faces being driven like that. So as you clamp onto the stock, you tighten the screw, and the screw is often underneath, it's down below, so you get this effect. Whereas with these, it's being driven straight out by a wedge, so it can't have any lifting effect. So it's a really solid clamping technique. You can clamp multiple pieces of stock, as I've already said. So for instance, I've got another locator here, put one in there, put another clamp there. The locators are also double-sided, so I could have a clamp here and a clamp here. That's why these are precision ground surfaces, so they wedge in accurately, and once you bolt them down, they're not moving forward or backwards. There are different sizes available. So this is the 50 series, so it's the smallest clamp. For my Haas UMC500, I can't get a massive piece of stock on the machine, so it makes sense for me to go with the smallest clamp. And the reason for that is that these eat into my work area as little as possible. So if you go with bigger clamps, they're obviously bigger, so they eat into your working area, so you can't hold as big a piece of stock. But I'm never going to hold a really heavy piece where I might need those bigger clamps. So the sizes of fixture plate, and clamps, corresponding clamps that come with them, are the 50 series, the 60 series, the 75 series, and the 100 series. And that is, the naming comes from the space between the T-slots. So on this there's 50 millimeters between the, or 5 centimeters between the centers of the T-slot grooves. On the 65, actually the 60, it's a bit confusing because the 65, I believe, or is it 60 series, sorry, fits on the 50 plate, I think, as well. It can be a bit confusing there, but the 75 is 75 and has its own set of clamps, and then the 100 has its own set of clamps as well. The other confusing thing that I didn't understand at first is actually you can put the 100 on the 50 plate, because if you think it's spanning 2 gaps, it's twice the width, so actually 250s makes 100. So you can put the 100 clamp in here, it'll span 2 gaps, and then the clamps in either side. So you could have the 50 series but still use 100 clamps on it. That's something I didn't understand when I first looked at this system. The 75, you can only use 75 clamps on the 75 plate. The other thing to note is that on this 50 series, I only have the T slots going in one direction, whereas you'll see that often on the 75 and 100 plates, they have them going in both directions. That's because one, it's not necessary on the 50, as I now know, but also it's not really doable, because if you have T slots going in the other direction as well, so on my machine this would be the X direction and this is the Y direction, so if I had them going in the X direction, it basically creates small islands. If you can picture the grooves going that way, and that means that these little stands wouldn't be, these little islands, wouldn't be strong enough. So that's why they don't like doing. They only put it in one direction. But that doesn't matter so much, because if I take this clamp and put it in here, what they also provide is these longer, I think they're also called clamps, and you can put these in the side like so, and they span 2 grooves, so you can't line it up exactly on the side, but it's good enough. So it's not quite as good as having the grooves going in that direction, but it's almost as good. The other thing to mention is that these fixture plates tend to be custom. So Matt at MicroLoc is really good to work with. He's really helpful. He'll answer all your questions. But you're best going to him, explaining what machine you have, and therefore coming up with a design for a fixture table that suits your machine. Right, so now I'll explain a little bit about the accessories that are available with the help of this locator here. So there's a few different jaw types. First of all, you've got soft jaws, which are available in both steel and aluminium. This is a steel one. So they're quite a tight fit. You can see they've got these little extrusions, and they almost pop onto the face of the locator or clamp, whichever one you want to put them on. So if I do that, just give it a press, probably not, there you go, and then kind of slide it down, but you see how it almost pops on. It's a tight fit, so it'll, if you take these off then put them back on, you should be able to get a very accurate fix on them, and then it just slides off. So fairly simple. As I say, available in both steel and aluminium. I'm not sure on the size of that, but obviously as the clamps get bigger, you get bigger ones. It's worth mentioning that actually, if you're doing small parts, these are very economical, because you can do lots of small parts on a single fixture plate if you buy lots of clamps and locators. But also, so you can machine multiple parts at once, but also they're pretty cheap for what they are. There's nothing more annoying than when you've only got a big vise, or a relatively big vise, and you've got a tiny part and you have to machine a big soft jaw, whereas these, really cheap for what they are. You can just you can mess it up and you're not going to worry, whereas I know on larger jaws then it can be more expensive. Downside of that is if you're doing larger parts, then this probably isn't going to be big enough for you, so you maybe need to think about using bigger clamps or so on, and locators, so that you can have a bigger soft jaw and therefore hold a bigger part. So that's the soft jaw. Then you've got these, which are called the serrated jaw, I believe. So I correct myself, they're called the Ultra Grip Facer, which I inquired, they used to have, if you look through their catalogue, they had something called the plain or hard facing, and these seem to have replaced them. When I asked to buy those plain hard facings, they were replaced by these Ultra Grip jaws, which have always been an option. So what you do have is that plain face there, but then you've also got this grip at the top, which will bite into your stock. So this is what you now use. And same principle, it's got the locator on the back, precision ground, just goes on the front like that. So these fit nicer than the soft doors actually, they're a really nice snug fit. That's that. Then you have these, which are, if I come up to the camera, you can see that effect. They're a serrated jaw, so those will bite into your stock really, really well. And those come in, all of these in fact come in 2 sizes, which is quite interesting. So they come in a 4mm depth like that, and then, if I put the locator down, a 4mm and an 8mm. And what that means is, if I put that on the front, you can see the 4mm, you can put your stock on that lip there or rest on the lip, whereas if you have the 8mm, it goes past the lip, so you can actually put the stock on something else. So you can, say you want to get it as low down to your plate as possible, you can use this extended face, and that will mean that the lip doesn't get in the way, and you can mount it directly on the plate or on some shim stock or something like that. And I think that is an option for all the different types of facing. You get that 4mm or 8mm, and on the larger locators and clamps it might be a slightly different distance, I imagine it is, but just bear that in mind. So yeah, that's 2 sizes there. You also have these in various different sizes. You get a packet, comes with it when you buy it. I don't know if you'll be able to see that very well through the packet, but all different sizes. They go on the front like that and just raise the stock up. So if you want a tiny clamping surface, this is the largest one, and then this is the smallest one like that. So again, just raises it up off that ledge rather than just clamping it with the face. In addition to that, you get these various accessories. Again, it comes with a packet, as you can see. So a whole load of these things. They're quite greasy when you get them, which stops them rusting. But the principle is, the locator has these threaded holes on the side, so you can put multiple spacers in and use that to locate your stock. So I'm not going to do it, but I'll just assemble one quickly. Do it like that. Put that down. So yeah, you'd screw that in the side like that, and then that allows you to accurately and repeatedly locate your raw stock. So quite useful. All different sizes of those come with it, so that's really good. And then I also mentioned that, just bear in mind, there are different lengths. I think this is the MV1 for my 50 series plate, and this is the MV3D, I think. So you can get different lengths of clamps, and I'll explain on my plate why that is useful in a moment. So now I'm going to explain a bit about why I went with this particular fixture plate. As I mentioned earlier, they are custom, or do tend to be custom. I think they have some standard sizes, but really for most people they'll be getting a slightly customized plate. So first thing to mention is that I went with the 50 series, the smallest series. The reason for that being that, as I've already mentioned, I'm putting it on a Haas UMC500, which is Haas's smallest 5-axis machine, or was until recently, where they introduced the 350 HD. That means that the table weight, the maximum table weight on that machine is 225 kilograms, I think. So it's really not a lot. So I'm not going to be putting anything on the machine that requires a massive clamping force. As I've already mentioned, these clamps are very powerful. Bear in mind that the bigger the series you go with, so say I went to the 60, 75, 100, that means bigger clamps, bigger locators, and a deeper fixture plate, so you're getting more weight into the work holding system, which means you can have you have to have a light, your maximum weight of part, I should say, is decreased. So by going with the 50 series, I'm maximizing both the size of part I can hold and the weight of part I can hold. Why am I maximizing the size of part I can hold? Because if you think about it, I put the locator at the extreme there and then the clamp at the extreme. That is the maximum size of part I can hold. Whereas if you go with the 75 or 100 series, you've got much bigger clamps and locators, and they eat into your work envelope like that. So if you're doing big mold plates on a big machine, then yeah, you may want to go with the 75 or 100 series, but for me, that would just be overkill, so I've gone with this. I mentioned also that the 50 series only has the T-slots in one direction. What I've done is get a central groove down the middle of this one, and that's so if I want to, for some reason, I can locate a clamp and a locator right in the middle. So that means I can get the gripping force in the center if I ever wanted to put clamps going this direction for some reason. So it just gives me a little bit more flexibility. You'll no doubt want to be able to lift the plate in and out. Some people have pallet systems. I don't. I have a Lang fixture plate on my machine, so I just change things in and out using their pull stud system. But everyone will need to lift it in some point. So my locator, threaded holes are in the four corners, and you just screw these eye bolts in like so. Really simple. So that's that. There are two holes in the middle of the plate, and I have to confess I have no idea what they're for. This is a 500 by 400 millimeter plate, so the plate is a standard size, although I've had some customization. I think the casting is a standard size, so maybe that's something that comes as standard on the casting. I don't really know. Or maybe it's something that MicroLoc used to bolt it down where they're doing machining it and grinding it. I don't really know, but I don't use those two sets of holes. I don't really know what they're for. So yeah, I have, because I'm putting on a Lang fixture plate, I have two pull studs underneath and two there, so 4 total. They're the Lang 96 pull studs, and that gives me more than enough force to hold this, clamping force to hold this onto my table. So yeah, those are a custom feature again. You can get them put wherever you want. It's best to just talk to MicroLoc. Matt is really, really helpful. Can't emphasize enough, because I was probably asking loads of stupid questions where he's pretty patient with me. So, and he's very quick to respond as well. So you'll go through the process very quickly. It's not like a long, drawn-out process. So that's that. Why have I gone with 500 by 400? I'll show you on the machine in a little bit. But I basically wanted to maximize the size of my work envelope, but also minimize the weight. So I could have gone 500 by 500. If I'd gone any bigger than 500, I would have had a clearance issue again, which I'll show you in a little bit on my tool setter. But I went with 500 by 400 because I'm clamping in that direction. That allows me to maximize the size of part I can hold. Whereas I thought beyond 400, I can just overlap a little bit, it's fine. With the part, whatever raw stock I'm holding or part I'm holding. But this allows me to bring the clamps kind of quite close to the edge. So yeah, I would recommend just putting this in CAD and having a play around. You'll see it's no coincidence that with a 500 like this, I've got the locator right at the very edge. That's because I modeled it up and realized that 500 was the perfect width to get a locator right up to the edge. So be clever like that, just kind of model it up, think about it, and you can get these the CAD models for these from MicroLoc, so you can make your own. They don't have like a fixture plate template, but it's fairly easy to model up. They've got the dimensions in their catalogue, so you can just quickly knock this up. And then yeah, just get these locators and clamp models and just place them on the fixture plate and have a play around, and you'll see what's right for your machine. So yeah, that's why I went for this. Now I'll show you on the machine and how it works for me. So I'm actually in the machine now. As you can see, it's a fairly simple process. Lang fixture plate, this is just a standard Lang fixture plate. I have got custom bolt holes for my UMC500, which is pretty much any machine you get, you're going to have to get custom bolt holes fitted. But aside from that, simple. It's got eight 96mm holes in it to accept the pull studs, 4 of which are on the bottom here. So all you have to do is just lower it gradually and line them up. I'm not going to do it now because I'm on camera, but you just give it a push in either direction, and it's really easy to line up yourself. So here it is actually in the machine. I'll just jog the table so you can kind of see the clearance there. So I've got plenty of clearance around the plate. I'll just go in the side of the machine and explain one thing. So this tool setter, actually, if you look at the CAD models supplied by Haas for simulation and collision avoidance and so on, they're meant to be exact. But one thing I found is when I modeled this up, I kind of swiveled everything, set some joints on the machine and swiveled everything round. and I checked I had loads of clearance between this corner and the tool setter. But if you look at the model, the tool setter is actually far further in, far closer in, meaning I thought I had more clearance than I did. Thankfully, I just put in some margin for error, and that means I've still got clearance, but it's something, when it actually did spin round for the first time, I thought, oh, that's closer than it's meant to be. Double checked my model and saw that, yeah, that was why. So it's something to bear in mind if you're relying on your simulation model. You know, you don't want to order a fixture plate, a custom fixture plate, and then find it doesn't fit, which would be a disaster. So yeah, I'll now go through the advantages and disadvantages. So first thing to mention is on the advantages, I would say overall I'm incredibly happy with it. I love it. I've already mentioned it's allowed me to do things I just couldn't do before. It's done exactly what I bought it for. So the main advantage is flexibility. I've held a piece, about a 70 kilogram piece of aluminium, well over 70 kilogram piece of aluminium in this, that I just could not have held in a large vise. On this machine, there's just no real way of doing it. But then also using that same system, I have been able to hold lots of small parts for doing things like dovetails. So here you can see I've got it set up on the machine making dovetails. So I've got stainless steel 304 in here at the moment. I've just got 2 pieces because these are the final 2 pieces. But I can have 4 pieces in here. Really, you can put as many on here as you want. I'm just doing it 4 at a time because that's how many of these clamping units I've got. So I've got the 2 locators in the middle, which have a face on either side, and then 4 clamps. So something where you've got like a 1 to 2 minute cycle where you can barely leave the machine, so you can't get anything else done in your day. You can now set 10 parts up on this at once, and then it gives you a meaningful cycle time, 15-20 minutes, so you can walk away and do some programming and do something meaningful. So it buys you time in your day, which brings me on to the second advantage, which is the price. You think, looking at this, a custom plate and all the little clamps and all the little locators and nuts and accessories and everything, you think it gets pretty expensive, but relative to the price of just a normal vise, thinking normal Lang or fifth axis vise, you'd be astonished at how good value this is. I can't remember off the top of my head, but get a quote because it's worth it, and you'll find that, again, for the time you save, especially doing small parts where you can load up the machine and go do something else, you'll find that it pays you back fairly quickly. And then also it'll allow you to do large parts that you just couldn't do otherwise. So those are the key advantages. Disadvantages, I've already mentioned the weight. So it's quite heavy. It's steel. You can get it aluminium though. So if weight is an issue, get it in aluminium. For me, it's fine. I'm not doing anything on this machine that is really going to make weight a problem, but for some people it might be. If you're on a 3-axis vertical, I doubt it would ever be a problem because those 3-axis verticals can take a lot more weight than a 5-axis machine. So just something to think about. If you're looking to save weight, you can chop the corners off like that. You can do various things to just lightweight it. I don't know whether they can kind of machine out the bottom in places as well. They probably can to just save a bit of weight. They're very good. Matt Janess at MicroLoc is really helpful and really useful. He's a good guy to talk to. Yeah, all the accessories are really cheap. I've already mentioned about the soft jaws, where if you're doing small parts, lots of small parts, buying those little aluminium soft jaws is a great way to get loads of parts done on a second op for not a lot of money. And they precisely locate onto locators and the clamps. So what you've got in here can match your CAD model. I did have to create my own fixture plate in CAD, but it's really not that hard. If anyone needs that doing, just give me a shout and I can help you if you want. I think MicroLoc will probably help you as well. But that's something I just did myself because it's fairly easy for me. They do supply the CAD models for the clamps and the vices. I'm going to show a little bit on how to do that, how I've set it up. Because obviously on a 5-axis machine, you've got to really simulate everything you do. So I set it up exactly as it is in my CAD model and CAD CAM, exactly as it is in the real world. So I'll show you that in a bit, but that's just something to think about. If you struggle in CAD, maybe you might need some help with that, and that'll cost you a little bit more. Whereas like a self-centering vice is a little bit simpler because you're just doing that with it really. Whereas these is a bit more positioning work. So yeah, I use Fusion 360, and setting up the joints isn't that hard. I'll show you how to do it, but it's just something to think about. Disadvantages aside from that, there really aren't many. Maybe the clamping range on the clamps themselves, they don't have a massive, you think with a vice you can kind of put a piece of stock in and just wind it up, whereas you have to be a little bit more specific in where you place these things. So say you've got something hanging from a crane and you're going, hang on, how far away do I need this? It can be a little bit fiddly like that, because you've got the racks when you put them in the locate them onto the fixture plate. They've got those tiny little teeth, so you're moving them forward in increments, and they don't have a huge range on the tightening. So that's maybe another disadvantage. For me, that's not really been a problem, but for some people it might. I've got that crane, as you just saw, with the electronic up and down, so I find lifting things in and out fairly easy. Craning it in and out, as you've seen, is really easy. So yeah, aside from that, it's all good. And now I'm going to show you how I've set it up in CAD CAM, so you can just get a feeling for how easy that process is as well. Right, so now I'll show you how to set this up in CAD. First of all, I'll design the fixture plate. MicroLoc do actually supply handily the CAD files for their locators and clamps, but because your fixture plate will likely be custom, you'll have to design this yourself. So you see I've got my UMC model here, I've got my Lang fixture plate underneath there. I'll scroll the timeline back a little bit to this sketch 7. What you'll see I've done, if I click edit sketch, is I've patterned or put a pattern with the dimensions of the fixture plate, so 500 by 400 for me, and I've put the pattern of the 50 series, so it's fairly simple. 50 gap between them, and then 6mm at the end of each. I don't know what they call these, extrusion or boss or whatever, which measures 38. So you just do that, do one row, and then if I continue, you see I've started with a solid block, then I've just extruded it down like so, put a sketch on the end, you can see that, and then I extrude these two areas here, so that gives you one part of the fixture plate, and then I just pattern that along and then extrude. If I go back to extrude this area, this outer area, and that gets rid of the excess, and then do a combine to join all together. So that's a fairly simple process for getting yourself a fixture plate. If you have the T-slots going the other way, pretty much just draw this sketch, but draw it on this side and extrude the areas again, and then pattern them along the plate. Along the side of the plate, and then you'll get your T-slots going in either direction. So pretty simple to do that and set it up in CAD. You'll see in this design file I was playing around with a few other options before I went with MicroLoc. So just to give you an idea, if I put a clamp on, I think I've got this here. Right. So I've put two Jurgens vices on top of the Lang fixture plate, and you can see it gives you a rough idea of the size, because I was thinking the MicroLoc might be a bit bulky for my machine initially, but you can see you're putting stock on there, or you can actually, as I mentioned earlier in the video, put it on top of the plate itself, whereas with the Jurgens you can put it on this lip here. So if I go side on, you'll see where the two levels are. So the Jurgens is actually sitting slightly higher, a big Jurgens vice, and if you put it down in the vice, it'll be about the same level as putting it directly on the fixture plate. So the MicroLoc actually isn't eating into your Z height any more than just two big vices would, but it gives you a lot more flexibility. So that's quite a good illustration of why I went with the MicroLoc over going with a big vice or two big vices like I've got there. Something I'd really recommend doing is setting up joints. On if you've got a model of your machine, set up some joints so you can simulate its movement like I've done here. For me, this is pretty important for just working out clearance, and I think if you've got a 5-axis machine, this is really worth doing. So for me, the main issue is on this tool setter, so I'm pretty glad I gave gave myself some clearance on that because it actually in real life sits further out than it's modelled here. So I was really concerned about this point and whether I'd get a collision, so I kind of just played around with the table when I designed it and just moved this around to get an idea of how much clearance I'd have. So I definitely recommend doing that. And then the next thing you want to do is place some locators and clamps on it and figure out, have you got more table than you need? For instance, this is the 500 is the perfect length of table for me. There's no point in me having it any longer because this locator can't move any further back. So anything out here would just be added weight for no reason, which again on a 5-axis machine is quite important to try and keep the weight down. So just something to think about. Really helps in the design process and is worth doing. Right, so now what I'll do is show you how to set it up for a cam. So if you want to hold a piece of stock, and then you can simulate your machining program accurately. So what I did is, this is my experimental design file. So I just saved this plate as a component, or in here it's a body actually, and then put a joint between it and the line plate because that's always going to be how I've got it set up. You can see it, I've already inserted a locator, so you just go right click on there, insert into current design, and then it will appear in here. And then it's a pretty simple process. If you're going to join, just an ordinary joint, select simple joint, and what you want to do is just select the corner of the locator, doesn't matter which corner in there, and then select a corner like that, and there you go, you've got your locator in position. Then what you want to do is just set up an offset plane. Now it depends on whether you're putting it on the table or on this little shelf, but I'm going to put it on the shelf today. And by it I mean the stock, whatever you intend to machine. Put a sketch on that plane, and then I'm just going to do a simple square piece of stock like so. You can decide where you want to position it and so on. What I then do is project these edges. So project, and I draw a little square, or make a square. Make these horizontal. And I make these as long as I intend the jaws to be. Remember earlier I mentioned they've got MicroLoc make a 4 and 8 mil jaw, so I'll make these 4. Click OK. Let's make the width, I don't know. Right, let's make it 200. Let's make the length 350. No, 350, not 250. So that is the outline of the stock. What I do quickly is just create a new component and just say jaw. Then I'm going to extrude that there. It depends how accurately you want to simulate. Most of the time I wouldn't even bother making that. I'm just getting stock in the right position. I don't need the jaw to actually be there, but I'm just doing this as an illustration. So there's the jaw, attach the locator. Right, let's get that sketch up again. And then we can create the stock. So again, new component, stock, extrude, I don't know, 100, that'll do. And then you can do this with as many locators as you want. With the clamp I do something a little bit different. So if I've inserted one down here. Sorry, this is a bit confusing, but because it has this moving jaw, the length of the clamp can change. So what I tend to do is actually set it up in real life and then draw the clamp in and just make a simple body for the clamp. So I know that the clamp, if I measure from there to there, so it's a maximum of 45.13 off the table fixture plate. I also know its length is roughly going to be 64 millimeters long by 31.7 wide. So if I just draw that as a square, if I go back to that sketch, so edit, or a rectangle rather, bring up the line command. So if I go 64 by, what did I say it was, 31.7? I can then position this at 31.7. I can then position this accurately on the table. So what you might do to just get it central is project this edge here, like that. Draw a line between 2 points, like that, and then this have that go from the midpoint there to the midpoint there. Make it vertical, and there you go. It's self-centering. And then, what did I say the height was? I think it was a maximum of 41 point something, wasn't it? 45.13. Sorry. Right. So close that. Create a new component and just call this clamp. Extrude. Want to go from the fixture plate, distance of 45.13, and there you go. And you can measure it in real life. I mean, for simulation purposes, you're going to get a pretty accurate representation here, but just measure it in real life and change this length, and that's how I do it. It's the easiest way to do it, and it's very accurate. You're gonna, from a collision avoidance point of view, it's going to accurately simulate what you've got, and it just makes it easier than trying to get this model to work for you. So that's the way I set it up in CAD, so that I can simulate CAM operations. It seems the easiest and quickest way to do it. As you can see here, it's pretty quick. And then again, use the pattern function, just help you make things easier. So if I pattern that along, say, that axis, you can just move them to wherever you want them. So if I take that down to 2, do 4, do as many as you want. I probably just want 2 actually. And you can just really easily locate them. So we're dealing in increments of 50, so 150 is going to be exactly where you want it. Just do it like that, and you've got 2 clamps. Very, very easy, very quick to set up, and another advantage of the MicroLoc system.